My name's Josef Karthauser, and I'm co-founder of a new startup actually called Dr. Dots. And I'm very grateful to Wolfram for inviting me here today. Thanks very much. We're exploring an idea, and that idea is, how do we teach kids to think mathematically? Not to do maths, but to actually think maths. My colleague Dr. Rob McDuff has been developing a curriculum and trialling it in the US for almost a decade now, with inspirational results. And earlier this year we decided to team up and take these ideas out of the classroom and bring them to a larger audience through interactive software. I'd like to start by asking a question. How many of you think that maths is just hard? And as a consequence, we can't really expect all our kids to get it. No one. That's fantastic. So how many of you think that there are some kids that we can't reach at all? Yeah? Doesn't matter what we try. We really want all of our kids to learn maths, right? All of them. But the simple truth is that just a small proportion of them actually can really demonstrate their ability and go on. We just heard today that 50% of our adults aren't performing more than a 13-year-old. So there's some disparity in the room. Why is that? So, we all hear this story. Sometimes from parents, they say, well, I wasn't very good at maths. And so, my kids are not very good at maths either, but that's okay. It's just a gene thing, or it runs in the family, or we're not smart like you are. I hear that a little bit sometimes. What they really mean is, what are you talking about? Well, I totally disagree. I think that we can teach kids quite complicated mathematic ideas. Maybe not even teach them. Maybe they can come to these realizations themselves at a much, much earlier age than we're targeting. Let me show you something. This is Kale. He's my 5-year-old. And he's just playing with some software that we've thrown together for him. He's just noticing for things that are the same and things that are different. I just want to run this for a second. Okay. Can you make a group of 3 dots? There we go, that's a group of 3 dots. Can you make 2 groups of 3 dots?
When I put the 3rd dot in, it turns green.
Have you got 2 groups and 3 dots there?
Mm-hmm.
Can you point to the 2 groups? That's right. And can you point at the 3 dots in each group? That's right. How many dots do you have altogether?
6.
How many?
6.
Perfect. Now, can you make an empty group? And then take a dot from each group and make 3 groups of 2 dots? So, Kale knows about 3 groups of 2 dots and 2 groups of 3 dots. He knows about things that contain things. He's only 5. And he doesn't know that they're equivalent yet. He hasn't worked that piece out. But what he does know is that there are things that are the same and there are things that are different. Now, again, he doesn't know algebra. And, this is kind of not quite pre-algebra, but just have a think and notice what he's doing. Imagine what's going on in his head.
So 2 dots at a green in 1 group of a blue dot.
Can you see where in the sentence refers to the 2 groups of 2 dots?
That green thing.
That green thing?
The green writing. Yeah.
The green writing?
Yeah.
Cool.
It says 2 group 2 dots. dot group.
So Kale is beginning to explore the idea that a sentence, a symbol sentence, an expression, refers to something else. It's a language that is used to describe something else. And he's still exploring this connection. He's still trying to work it out, right? I mean, he doesn't know how to manipulate it. He's not being taught to manipulate it, but he's using it as an expression. He still thinks to group, to dot group. These are words for him. And he's learning this containing structure. He knows the structures. He can play around with them. He understands them. And he's beginning to build a referent connection with the thing that the sentence is pointing to. So here again, this is him engaged in play. And he's forming some theories.
Look. And then I know the same. But look what I can do. No.
Oh, it's not blue anymore.
It's pink.
Why is it not blue?
Because it changed. I know why it changes colour.
Why is that?
When blue and blue mixes colour, it makes pink.
So, they're not mathematical theories yet. But it's clear and clean, isn't it? He's capable of making distinctions, even at this age. He still thinks these dots are magic. He moves the blue dot around, and as it goes into one group and out of the groups change their structure, they change their colours. Their colours are their names. So two groups that have the same colour are the same structure. And he knows this, but it's the dot that makes the difference. He says it's a magic dot. So he's working with this. Now, you know what's happening in our schools, don't you? We're teaching our kids to do computation. We're teaching them to do 2-digit addition and 3-digit multiplication. We're even teaching them long division. We're teaching them all kinds of algorithms, aren't we? And we're teaching them in the hope that they will learn how to think mathematically. But is it working? It doesn't seem so. If you look at the States, in the US, they spend more money educating their kids than any other two countries that you can put together. And what results are they having? Well, they're way down on the league table with their kids' mathematical abilities, aren't they? We're not much better. We heard earlier on that the May Ofsted report, of 13 to 18-year-olds in maths, what's that? 10% are not reaching the expected grade at age 7. By 20%, by 11, that's 20%. A fifth of our kids, by the end of primary school, aren't reaching the levels that we set, and we know what happens after that, and adults and all the rest. 2011, 36% didn't get grade C at GCSE, and we think this is okay. It's crazy. But what does it say about our kids' ability to do mathematics? What can we do about it? I'm so worried. I have a 5-year-old, Kale, and I've got a 3-year-old, Simran, and I want them to be able to live in this world that we're moving in. I don't know what that's going to be in 10, 20 years' time. I don't know what content to give them. What I do know is if they can learn how to think and reason, they'll find their way to the content. But in school, they're just going to teach them addition and sums. It can't be right. So let me leave you with one simple idea. Instead of using computers to make it easier to do computation, why don't we instead use computers to aid a kid's ability to think and reason? How you go about doing that, that's a complex story, right? And what we've done is we've developed some software, as you can see. But here we have a kid who's 5 years old. 5 years old, just 5 years. And look what he's doing. Look at the maths he's doing at that age. And it's not like he's been doing this for 6 months or a year or something. If he spent 10 hours on this thing, that would be a lot. Just think what he'll be able to do when he's 6 or 7 or 8. And when our kids are learning to think and reason, when they're 18, what will they be teaching us? Isn't that what we all want for our kids? Thank you.